This quick video will talk about hydrolysis as well as providing additional pH practice. Now the word hydrolysis has two components, hydro, which means water, and lysis, which means to split apart. So therefore, hydrolysis is the reaction of a substance of any chemical species with water or its ions. If the ions of water is going to be hydrogen and hydroxide. Now, depending on the predominant reaction, water can either accept a hydrogen, act as the Bronsted-Lowry base, or it can donate a hydrogen, which acts as a Bronsted-Lowry acid. Let's look at an example on the next slide. Our example here is what reaction predominates when sodium hydrogen sulfite reacts or dissolves in water to produce hydrogen sulfate ions. Will the solution be acidic or basic? Will the hydrogen sulfite act as an acid or a base? Because hydrogen sulfate can both accept a hydrogen to produce hydrogen sulfite, or it could donate a hydrogen to water to become sulfite ions, 2-. It can act as both as an acid or a base. So we need to figure out which is the predominant reaction, which reaction will happen more often. The first step we need to do is to look up the Ka value for our hydrogen sulfite when it acts as an acid. So if we see on our strength of acid-base tables, the Ka for hydrogen sulfite is 6.3 times 10 to the minus 8. The next step is to look up the reverse value. We now have to look up the Ka for our conjugate acid. So therefore, we look at our table, we find that the Ka for H2SO3 is 1.4 times 10 to the minus 2. However, when we do our next step, we have to convert the Ka value into the Kb. Why is that? Because the Ka is only for the conjugate acid. It's only for the conjugate acid. We actually need to compare the Kb for hydrogen sulfite with the Ka for hydrogen sulfite. We have to compare the Ka for hydrogen sulfite with the Kb when it acts as a base for the hydrogen sulfite as well. And we'll find the Kb on the next slide. So again, we have to find Kb for HSO3-, and the way we do that, we have to look at the Ka of the conjugate acid. We know the Ka for conjugate acid is 1.4 times 10 to the minus 2, and we can determine the Kb by dividing by 1 to 10 to the minus 4. So we figure out the Kb is 7.1 times 10 to the minus 13. Now we have to compare this Kb value with the Ka. So the Ka, now down here, for HSO3 is 6.3 times 10 to the minus 8, whereas the Kb for the same entity, the same hydrogen sulfite, HSO3-, is 7.1 times 10 to the minus 13. The Ka value is much bigger by order of 10,000, 10 to the 5. So therefore, we know that this is the predominant reaction because the equilibrium constant is bigger. So the solution, because now the Ka value predominates, will be acidic. That is, HSO3 will react with water to produce hydronium H3O+ and SO3 2-. However, this is a very, very weak acid. The Ka is times 10 to the minus 8. So this reaction, even though the forward reaction will predominate, it will not happen a lot. So in summary, when you're trying to determine which reaction will happen, the acidic reaction or the basic reaction, you have to look at their equilibrium constant and determine which constant is bigger.